Okay, great. So let's get started. It's a little past 11, but I suspect everyone's a little hungover from the party last night still. Cool. So I'll start by chatting a little bit about who I am. My name is Karla. I work at Stripe on our identity team. So that's a team that does like security for our users rather than security for the company. So you can see this as like adding new 2FA primitives to our website, like trying to detect if someone logging in is actually the real user or if there's someone pretending to be the user who's, for example, stolen their credentials. But I actually used to work on our internal security team. And as a consequence of that, I've done a ton of internal phishing training at the company and run a number of campaigns against employees and stolen approximately half of the company's credentials at some point or another. So this is basically going to be a bit of a story about things we've learned from that and how we think you should protect yourselves. So let's start by talking about what we're even going to talk about today, right? Phishing is a pretty huge space. There are a lot of different targets and a lot of different actions that you can take. And so we're going to cover specifically cases where phishing is targeted towards people whose operating systems and setups you can have some impact over. So this isn't covering like how do you stop end users from getting phished who are on like a multitude of different operating systems and browsers, but specifically how do you stop your own employees from getting phished, or how do you stop like the employees of a company you're contracting with from getting phished. And we're also going to talk specifically about targeted attacks. So we're not talking about like the lowest common denominator, like, oh, someone like stole some SSNs here or there and incidentally they got access to your company network. We're talking about people who are actively trying to get into your company specifically. And we're going to talk about this in 3 sections. First of all, we're going to chat a bit about the psychology of phishing. Why do people fall for phishing attacks and like how can you make your attacks more effective? Then we're going to talk specifically about the story of phishing at Stripe, what worked, what didn't, the sorts of training we did. And then we're going to make some recommendations based on the things that we've learned ourselves. But let's start with like, why do we even care about phishing, right? And specifically targeted phishing. That's a pretty specific attack. Does it actually matter? I mean, evidently phishing attacks cost a little bit. 1.6 million would be great to not lose. But more importantly, we see targeted phishing attacks in the history of security of like the last 10 years or so. In 2011, RSA had their master key phished. That's the key that's used for secure ID tokens. So those little tokens that you get for RSA, they lost the master key to that through phishing. In 2014, ICANN, the like service that helps identify services on the internet, lost their centralized zone data system passwords and credentials. And in 2014, Sony, the releaser of movies such as The Interview, actually lost a ton of access to their data. You probably saw it. It was in the news a lot because they had their Apple ID credentials phished. And that was used to escalate to email access. Interestingly enough, that's actually why Stripe started caring about phishing, because we chose to take payments for The Interview that year. And when you have North Korea potentially coming after you, it's probably a good thing to pay attention to attacks that they've used in the past. And this is a really interesting part because the security community cares a ton about 0 days, but they tend to kind of accept phishing as something that's really easy to do and it only happens to non-technical users. This is the stereotype, right? A Nigerian prince has reached out and would like to offer you some money if you would just send him your bank details and other identifying information. You'll also see this as like, your webmail quota has been exceeded from the IT administrator. Please send your username and password and they will increase your quota appropriately. We think that it's only people who don't know what they're doing who get phished. And I'm here to tell you that I'm pretty certain that is wrong, right? I work at a company with a ton of really smart engineers. Most of the people I target in my campaign are software engineers who should know better. So let's chat a bit about psychology. And specifically, we're going to be talking about psychology from Daniel Kahneman's book called Thinking Fast and Slow. And he posits that there are kind of 2 different ways that your mind operates, one called System 1 and one called System 2. System 1 is very fast, it's very instinctive, it's emotional, it's gullible, and it's what you use like most of the time day to day. It's very focused on pattern recognition and that sort of thing. System 2, on the other hand, is the slow, methodical, rational, careful side of your mind. When you sit there and you're like, oh, should I invest in this particular business opportunity? That's System 2. When you decide what you're going to have for lunch, it's probably System 1. And you can see this a lot in your day-to-day life. If you think about when you're driving a car, when you first started learning to drive, you made a lot of really careful decisions about whether you were going to turn here or there and like how you should respond if someone ahead of you is braking. Now you drive at like 60 miles an hour on the freeway. If something jumps out ahead of you, you probably swerve or brake without even really consciously thinking about it. That's your System 1 brain working. Your conscious mind doesn't actually have much impact on it. It's the source of a lot of biases and a lot of other things that we would typically consider to be negative, But it's very important because it's faster than System 2. You couldn't possibly go through your day-to-day life constantly making very deliberate choices about what you were going to do. You make a lot of unimportant choices very quickly using System 1. And this is a big problem because in the modern world, there's a ton of information available to us. In reality, we're all pretty time poor. Think about how much email you receive in a given day. I don't know about you, but for me, I get like 50 to 100 emails a day. I'm probably not analyzing each of them specifically for whether or not I think they're legitimate or fake. And this is the core issue behind phishing that's targeted towards a particular site. And phishing training in general. Phishing training is only going to help you if you make it to System 2 thinking. It's not like, oh, I'm automatically going to assume an email could potentially be suspicious. It's if I see something that seems out of the ordinary, that's when I'm going to start to pay attention to whether or not I think it's actually real. And the thing is, a well-designed phishing campaign isn't going to seem out of the ordinary at all. It's going to seem completely like a standard email that you'd receive. So let's break it down a little bit further. We've talked about phishing in general, but in this case, I'm going to break the space up into 3 different types of phishing. You can think of these as being action-based. So that's emailing someone on, say, a finance team and being like, hey, could you transfer this money offshore? I'm the CEO and we've just acquired a company, but I'm on a train and I don't have access to my normal email account, so I'm messaging you from a personal one, that sort of thing. That CEO scam is action-based phishing. There's exploit-based phishing, which is where you convince someone to open a malicious file and end up getting code exec on their machine. And there's credential-based phishing. So this is where you email a user to try to steal some of their credentials. You might see this as I need you to view this secure Gmail document, click the site, you get a prompt for your Gmail password. That's credential phishing, and it's usually used to escalate from there to other services. And each of these different types of phishing have different defenses that you would want to use against them. Action-based phishing, you can use something like security controls against. So if you only need, potentially you need 2 people to sign off on a given action, that's a form of protection against action-based phishing because now you need 2 people to fall for the scam. Exploit-based phishing, you can use things like mandating that your employees update their machines and that sort of thing. Credential-based phishing, we don't really have a great solution for as an industry at the moment. If you think about it, we'll train people to not click links and then they won't type their Gmail password into the wrong website. But that doesn't actually work out that well. So at Stripe, this is the form we focused on, partly because this is specifically what was used against Sony for this interview attack. Apple ID phishing was stealing a password and then escalating from there. So that's what we wanted to protect against. So if you imagine the structure of a credential-based phishing attack, there's kind of 3 stages. You have a hook, which is the email that's sent. Oh, I really need you to view this secure document. You have a phishing site, which pretends to be the site that they would need to enter credentials for. And then you have a trail out, which is how do you convince the user afterwards that they weren't phished? Because particularly for credential phishing, if someone realizes that they've had their credentials stolen, they will change them. That's going to render your attack entirely useless. So here you want the hook email to seem as ordinary as possible, but it also needs to contain some kind of call to action so that people actually want to go and type their credentials in. A phishing site needs to have a domain that's kind of similar to the original. Probably you want to clone it from the original page and host it on HTTPS. And then for the trail out, if possible, it'd be great if you could redirect to the actual servers. Because then someone's typed in their password, but they ended up on google.com in the end anyway, so it's probably legitimate, right? So let's move on to some actual real-world examples of this. This is an email that we sent out. Take a look at it. See if you can figure out anything that indicates that it's legitimate or not. We actually do use Slack internally, so you can take a look at that. Cool. Then compare it to this email. Which of these 2 do you think is legitimate and which one is fake? How could you possibly tell? Here's the 2 side by side. Does anyone have any particular feelings about which one they think is legitimate? This is the audience participation part. Yeah. Oh, there's nothing in particular below the stripy line. That's just the name of the company. Yeah. You think the one on the left is fake? Why? Single sign-on enabled. That's actually the legitimate one. It's the one on the right that's been faked. So the left one is one we turned on because we enabled single sign-on for our Slack instance. And the one on the right is the one I sent shortly afterwards. And it turns out there's actually not enough information on this slide for you to possibly tell. The email address is literally faked to be the same as from actual slack.com. Both emails were, like, the fake email was cloned from the real one. In this case, if you had hovered over the link, you would have noticed that it went to an HTTP page because I didn't have very much time to make the campaign. That was actually what ended up causing pretty low conversion rates throughout the whole flow on this. But this is something that's really easy to fall for. And I can tell you that that's true because I had to ask the VP of engineering for permission to send this email. And so I told him, hey, I would like to send a phishing email and I'm going to send it to you right now for you to vet. And he was like, I haven't gotten it yet. I don't think I've gotten it yet. Oh, wait, is it the Slack one? Like, he knew that I was going to send him a phishing email at that instant, and he still almost fell for it. This is someone who's plenty technical and knows better. And so it turns out, yeah, the easiest way to craft a realistic phishing email is just take a real email and then, like, make it say whatever you want it to say and change the links to where they need to go. As I said, we didn't actually get great conversion for the full flow on this because we used an HTTP page. And interestingly enough, this actually leads to another thing, which is that campaign's not possible anymore. It's not actually possible to spoof mail from slack.com anymore. And that's because there's a number of different technologies that have come out since we run that, or have, like, become more prevalent. One of them is SPF, which is the sender policy framework. This allows a given domain to say, I should only be able to send emails from these particular IP addresses. It's a TXT record on your domain. And that allows you to at least limit the number of email providers who can pretend to be you. But unfortunately, the client needs to check that. So if someone's using, like, webmail that isn't from a particularly secure provider, there's not really any guarantees that that's actually being enforced. Then there's also DKIM, which is the ability for you to sign messages with a private key and post the public key as a special record on your domain. And you can use that to verify mail as well. And you can use both of them in combination with DMARC, which is actually the Domain Message Authentication Reporting and Conformance spec, but which everyone calls DMARC. And essentially what this does is it allows you to say, given that a mail was not signed by me, what actions should I take? Should I consider it more suspicious? Should I hard block it? That sort of thing. So you as a domain provider can specify how legitimate you're okay with your mail being when it's received. But again, in all cases, this requires client support. So let's move on to another example. This is another email we sent. So we fast forwarded a couple of months here. There's been some more time. People have seen a phishing campaign in the past, and they hopefully would now know that phishing could be pretty convincing, I guess. And in this case, we wanted code exec, right? It's great and all to steal Slack credentials. That gets you some information. Stealing GitHub credentials would get you code execution, for example. So you, like, commit something, wait for a developer to deploy. Congrats, you now have code exec on a remote server. So this was the message we sent. The email address is really my email address, and it's really the name of my SSH key. The fingerprint there really was the fingerprint of my SSH key at the time. This is actually publicly available information on GitHub. So even if you'd gone to github.com and tried to verify that there was some shared secret, there's actually a secret that people give away everywhere. And it led to a really interesting piece of science for us. Should we send these emails in plain text or HTML? GitHub sends all of its emails in plain text, presumably because they're like, oh, they're way harder to phish, like, developers don't care about the pretty emails. So it was like, okay, let's do some science. Let's send half of the emails in plain text and half of them in HTML and see which ones get better conversion. We got about 10% conversion on the plain text email and like 50% conversion on the HTML email. Just made it look like the actual github.com site. It turns out that emails don't actually need to look like the real service. They just need to look kind of pretty, and people will think that they're legitimate. So this is the actual page that we used for that. The left is the real github.com login page, and the right is a real github.io hosted page. GitHub.io is a domain actually owned by GitHub. It's specifically for user-generated content. It's GitHub pages. So it's designed so that you can host your own blog on GitHub. But helpfully at the time, they also had a redirect, such that if there was a.github.com did not exist, they would redirect to a.github.io for backwards compatibility reasons from when they used to host GitHub pages on github.com. So what this meant was you could link to logln.github.com, have it redirect here. It's a real HTTPS site. It cost me absolutely nothing. I don't even own this domain name, and it's hosting a fake version of the GitHub login page. There's a couple of subtle domain differences here, but unless you specifically know how GitHub thinks about its content and where it stores user content versus real content, you're not going to know if this is legitimate or not. And so we thought about this at Stripe. We thought, okay, our users aren't super great at doing this. So we'll give them all password managers. We'll install a password manager on everyone's machine. As part of spinning up, you will learn, like, you should use a password manager that generates unique passwords and will, for example, prompt you as to whether or not a site is legitimate. So if you clicked on like one password or whatever, it wouldn't automatically autofill for github.io because it's not the same domain. But it turns out that if domains look similar enough, users will still copy paste out of them anyway. And we know this because we actually looked at keystrokes on this site. And we waited to see whether or not people were typing their passwords in by hand or whether they were actually copy pasting out of something else. And about half the users were copy pasting out of something else. So they had a password manager or some way of storing passwords and they were ignoring the advice being given by it. And just for completeness' sake, this is the page that we redirected to afterwards. It would legitimately list the keys that you'd seen in the email. It's legitimately hosted on github.com. And so this is about where people say, okay, sure, but I have 2FA turned on, so I'm fine. I'm totally protected. And that's great. 2FA is a really helpful security primitive. It means that your credentials stolen on the wire can't be used again. It provides one-timeness. But it doesn't actually protect you against phishing. You might say, oh, I have like SMS turned on. They won't possibly know my phone number. But if I run a malicious site, I can just proxy a login request to the real service, have it send you a text message, and then just use that text message myself and redirect you back to the original site. If it doesn't work, you'll be like, yeah, that was a little weird, but I don't know, like the web breaks sometimes, I'll just try again. And the second time, it's going to work. You're probably not going to think that's suspicious. 2FA is really important, but it solves a different problem. It's solving the problem of password dumps and shared credentials on different services. It's not solving the phishing problem, despite what all the advice online would have you believe. And so like it incidentally makes it a little bit harder to phish people, but doesn't actually solve the core problem. So at this point, I was getting a little skeptical of phishing training in general, right? We'd given our users all these password managers and we told them, if you have a password manager and it doesn't autofill, you shouldn't enter your credentials on that site. And it turned out they were doing it anyway. So we were like, okay, let's do some more science, right? We're an engineering company, it would be good to do that. So we thought, okay, we will show people a site that we are going to phish 3 months later. And we will show it to them during interactive phishing training in which they play the same game you did, guess whether or not you think this email is legitimate. We'll say this particular website, it's really hard to tell whether or not it's legitimate because it has a confusing URL. And we'll see if people actually remember that a couple of months later. And we thought, okay, what's better than code exec? Well, having access to all the servers is better than code exec, like administrative access to shut down and start up servers. So we use AWS. So I thought, okay, let's phish for AWS credentials. So during our phishing training, I showed this slide and I said, this is the actual login page for Stripe users and AWS users in general to access IAM. This is what the URL looks like. Everyone can tell the difference between Dropbox and DoNotBox, but this one's a little bit more difficult because it looks kind of sketchy to begin with, right? This is actually what it looks like. Complicated URLs are really hard to phish. You need to pay attention if you see them. And this is the actual one on top and the fake one on the bottom that we sent out 3 months later. We sent this with an email from the head of the security team. We actually have SPF and DKIM set up on our domain, so it's use a Gmail bug in the way it renders to actually fake email from a real person at Stripe. But I did that. And I said, oh yeah, like it's a beta product, so like it's not on the main AWS domain, but it's totally fine, pretending to be from the security manager. I also, at the time, happened to tell 2 friends of mine, I'm going to be running this campaign in like a week or 2 because I needed their help with some HTML stuff. And they had some more background on how to hide password input stuff. And so 2 of my close friends, one of whom works on security things at Stripe, knew that I was going to send this email out. One of them completely fell for it. The other one made it to the fact that their password manager didn't autofill, DM'd someone who, like DM'd the person I'd faked the email from, then figured out what was going on and was like, fuck, because he had gotten so much closer to being phished than ever before. But in general, we saw really good conversion on this. We saw about a 40% conversion rate for people who had, like anyone who opened the email, 40% of them made it to the page. And 2/3 of those entered not just their password, but also their 2FA credentials. Because we were phishing for those as well, of course. And this is really problematic, right? These are not trivial credentials to be stealing, right? If you stole enough of these, you could get root access to all of our servers. That's not cool. And this is training that we had given people a couple of months beforehand. So this pretty clearly showed to me that like, it doesn't matter how much you train your users, they are going to fall for phishing things. Yes?
Run any of these tests at different periods of time post-training to see if it makes a difference. In other words, what's the decay on terms of what you tell them?
Right. So the question was, did we run in any of these immediately after training so that we could tell like what's the decay on like people actually paying attention? I did not do that because I've only run them every couple of months or so, mostly because they take a couple of days to a week to set up. And this is like a side job for me these days. But I would say this is the one that was run most recently after phishing training. It was like 2 or 3 months later. And it saw like incredible conversion rates. Yeah, I agree. It would be cool to look at like how it works over time. So yeah, we saw pretty convincing conversion rates in general. And it kind of looked like phishing training probably wasn't working, or if it's going to work, it's only going to work for like 3 months at a time, if that, because like this is at the point where it's not effective anymore. And it's probably not realistic for us to train every single employee every 3 months. So this is the point where people tend to mention single sign-on, right? So they'll say, oh, well, it's all very well and good that you're phishing all these external services, but I have one authentication provider. No one would ever enter their credentials for that. So let's do a brief recap of how single sign-on works for anyone who's not familiar with it. So single sign-on has this general concept of I'm a user, and normally what would happen when I go to an external service is I would make a login request, and I would get back like, congrats, you've been authenticated, or no, you haven't been authenticated. It's kind of more like this because there's actually a lot of different external services you're using, and you potentially have different credentials, hopefully have different credentials to each one. We're going to focus on just one at a time. So an SSO provider essentially says when you make a login request to an external service, you will forward that up to an SSO provider who might potentially prompt the user again to enter extra credentials if they don't currently have a session. Then the SSO provider basically like returns that through to the external service, and then that external service passes it through as like you've been authenticated or not. And essentially what this does is it allows you to delegate authentication for any number of services to one authentication provider. So it ends up looking a little bit like this in the long run. And people say like, oh, well, that's fine. Like I have this one really secure service, so my users only log in once a day. They wouldn't fall for it at all. In the Bay Area, the common startup SSO provider is Okta. This is what their what their login page looks like, I should say. This, in fact, is Fastly's Okta page. Not to single either of these companies out in particular, but they have the shiniest one. I'm pretty certain I can phish this too. It's also got a username and a password. And more importantly, I can send an email for any service you use at your company, and you will enter credentials into this form. This is also not actually a great solution to the problem. And it's like super easy. It's terrible. So it's like, what now? What do we do with this, right? We've said that phishing training doesn't work. We've said that SPF and DKIM like kind of help a little bit, but not really that much because the client needs to support them and they can be worked around. We've said that you should encourage the use of password managers, but users will actually copy credentials out of them anyway. We've said that you should mandate 2FA, but it doesn't really solve this problem. We've said you can use SSO, but it also doesn't really solve this problem. Like, I'm all for realistic over perfect, but none of these solutions are actually particularly difficult to bypass. And this is like, people go, oh, well, I've got like this amazing detection thing, so I can tell when my users are doing performing anomalous behavior, and I'll use that to detect as soon as their devices are compromised, and that'll be good enough. But that's really dangerous because you're probably paging a human for that. And humans take time. Like, you've basically capped your incident response at 15 minutes minimum, depending on what your paging threshold is. And that's too much time, right? If I'm trying to phish your company and I have 5 minutes of access, I can just like go off and get myself some other credentials. And the time it takes for you to detect that is substantially longer than just 5 minutes. And this isn't even a particularly technical attacker we're talking about. We're talking about someone who's motivated for sure, but cloning an email, cloning a website, setting up HTTPS with like Let's Encrypt, none of that is difficult. This is something that a first-year CS student could do if they wanted to. And it turns out that like any human protection you put in place, anything that relies on a human making a reasonable decision or a human being involved in some sort of detection and authentication loop, that's going to fail. People are really, really bad at this. We saw our Amazon training fail to work. We saw like a friend who knew that this campaign was going to be sent, fall for it. In fact, 2 of them basically. The VP of engineering who knew exactly when it was going to be sent fell for it as well. This is all not actually showing that detection is good enough. So we're going to go back to the beginning a little bit, and we're going to talk about authentication factors. So if you think about authentication, there's kind of 3 different ways to prove that you are who you say you are. There's something you have. So this could be a 2FA device like a phone, or a 2FA device like a TOTP credential. There's something you know, which is like your password, something that you just remember. And there's something you are. So this is like biometric data, fingerprint scanners, that sort of thing. The web mostly uses no, that's passwords, with some amount of have for technical users and who enable 2FA. And basically we don't use R at all because biometric stuff is really a pain to do in a like cross-browser, cross-OS way. And so in order to prevent phishing, we need to make it so that it's not actually possible for a human to give away one of these factors to the wrong site. And so in practice, what this is going to mean is we need to tie these credentials to a particular service. Public-private key crypto seems like a probably reasonable way to do this. So if I can like somehow cryptographically tie the password or the thing they have or the thing they are to a particular domain, then it doesn't matter if they're phished because they're giving away credentials that are valid for the wrong site. And so at Stripe, we actually use SSO pretty heavily internally, but for our actual SSO provider, we use SSL client certificates. So these are basically every single machine we have is pre-blessed with a certificate. And that certificate identifies it as that particular machine. And when you make a request to a service, we do an SSL handshake, and the server verifies that the machine is who it says it is using public-private crypto. That means that even if you were to go like phish another, like if you set up a fake phishing page, there's no password for a user to enter at all. They don't have a password. They would have no idea what credentials to even enter. But also, even if that site tried to do an SSL handshake, it's just going to get a token from a private key, but it's not actually going to get the private key itself. So that credential isn't transferable to a new service. You can kind of think of it like cookies, but without all the downsides of cookies. It's great because you can't unintentionally leak them. It's a super awesome user experience because your users just like go to a site and it works. They don't see the authentication. It's happening transparently. But unfortunately, it has some of the downsides of passwords. This really sensitive, really long-lived credential. It's something that you can actually take off the machine, which isn't ideal. And it means that like potentially I could like, if I were feeling technical and like I didn't like the security team, I could take the client certificate off my laptop, put it on a phone, and now it's on this device that I trust substantially less. What we really want here is a concept of one-timeness. We want it so that even if you sniff a connection, having a client certificate isn't sufficient to authenticate. And ideally, we need this to use cryptography as well, because as we said, users will just like type in their 2FA credentials everywhere if they feel like it. And admittedly, it's like kind of a sophisticated attack where someone has stolen a client certificate and is then phishing for 2FA credentials, but it's still something that could potentially happen and that we'd like to protect against. And so we solved this problem with a protocol called U2F. You might have heard of it lately. GitHub, Facebook, Google all support this these days. And essentially what this does is it provides 2FA credentials that are bound to a particular device. So I have security keys that I have at home. And basically when I want to log into a Stripe service, I go to like an authentication page. It automatically logs me in transparently with my client certificate and then prompts me to touch this key. And what it does is it uses a browser support basically, where the browser sends the domain that it wants to have a credential for to the key. The key generates, as well as a nonce, I should say. The key generates a response which says, like, I sign that this particular nonce with this particular domain is valid for the next period of time. And that goes back through to the server. And we provide a cookie for the user that then validates them for the next n hours. And this is really cool because this credential is actually tied to the domain that you're currently on. So even if I go to like google.com and give away my password, when I try to use a U2F device, I might be able to phish for someone to tap the key, but that particular credential that the key is giving back isn't valid for the actual google.com. It's valid for like fake google.com. And this is pretty cool because Google actually allows you to mandate this for particular services. So you can say like, it is not possible for my users to authenticate with any form of 2FA except for this key. And that means I actually think it's impossible to phish Stripe's Gmail accounts at the moment because we tie all of these credentials cryptographically to a particular domain. And it's kind of cool. This protocol is actually seeing a ton more support. I mentioned that GitHub, Dropbox, Facebook are all adding support. But Intel's actually building native support for this into their chips as well. So in the machines that are coming out later this year, you're going to start to see support for this built into the actual hardware. So all you'll do is like somehow authenticate that you're present, and that will mean that you can actually provably tie your credentials to a particular machine. Unfortunately, it's not actually a panacea. There isn't really great mobile support for this at the moment. Using a USB device on a phone is not really a solved problem. There are some U2F devices that support Bluetooth, and that's gaining more traction, but it's still a little challenging at the moment. And what this means is most services that provide security keys also allow you to fall back to older forms of 2FA, like TOTP, which is Google Authenticator, and SMS. But hopefully, the goal here is that hopefully those swapping from that more secure method to a less secure method, at least at the moment, will cause people to think and like fall into system 2 thinking, basically, and think more heavily about what they're actually authenticating. Go for it.
So I saw a YubiKey there.
Mm-hmm. Yep.
I know Samsung is supporting NFC. Have they implemented the YubiKey protocol so that you got that drop-offs, whatever you want to on there?
Yep, so the question here is, this is a YubiKey FIDO device. Samsung, they also provide some not U2F, they provide NFC support as well. So they have ones that you can like just generally have in the vicinity. Does Samsung also support this given that they do NFC? I'm not sure. I don't think they do, but they might. In particular, the problem with supporting it on standard devices is that if the like secret for this particular key lives anywhere except in like a trusted module, then it's possible if you get code exec on a particular phone to steal it. I don't know if Samsung has built like TPMs into their phones yet. You could certainly implement it at a software layer, but you get less of the security guarantees that you get with a hardware key. Intel, for example, when they're doing their Shiny building it into the chip support, or actually building support in like for a trusted module into the actual chip, rather than like in a separate bus necessarily. Cool. And so we talked about how it's not got great mobile support, but hopefully it's coming in the future as more providers start to support it on the client side as well. The other problem with this is it only actually helps authentication flows that ask for 2FA credentials and passwords. So this is a Google OAuth flow. This doesn't require you to re-authenticate because you already have a session. And in fact, this is the Google OAuth flow that was used for Google Docs about a month or 2 ago. You might have seen it. It was kind of all over Twitter. Basically, what it would do is it would ask a user, hey, could you authenticate to Google Docs? Would ask for permission to manage your contacts and to send email on your behalf. Then would go through every single contact you had and send an email to them saying, would you like to share your Google Docs credentials? And see how this would form a pretty effective worm. And this is a real problem because there's not a lot on this screen that lets you authenticate who the real OAuth provider is. Luckily for us, we actually weren't affected by this because I ran this exact campaign a year earlier. So this is the email that we sent at the time. We don't use Google Docs very heavily internally. We used a service called Quip at the time, which is what this is pretending to be. And I actually thought that this email would be way too cliched. This is an email from the CEO about pay changes, which has got to be the most classic phishing trick in the book. So in particular, it's pretending to be a document that you were unintentionally invited to. When you clicked on that, it would send you through to this page, which as you can see looks exactly the same as the Google Docs campaign. This is a spoofed copy of their application, and granting access to this would lead you to a 404 on the real site. There's essentially no way for you to tell that this was illegitimate, except for the very fast redirect from a fake domain through to a real Google domain, which asked you to authenticate, and then back through a fake domain to the real domain. And if you think the Google Docs attack was successful, remember that those mails were sent to hhhhh@mailinita.com and BCC'd to the user, because the person sending them was kind of a script kiddie. These were actually sent in a really targeted way to our users, and we saw quite ridiculous conversion rates. Like given that you saw this prompt, there was something like an 80% chance that you would grant access to the application. This is people granting full access to their email accounts. It's kind of terrifying. You can imagine how much damage you could do with that. Think of all the sensitive information your employees have. Given that 80% of them who see this email click through to this, that's not great. I actually learned from this particular attack that you should not spoof email from the CEO without asking first. That led to some exciting drama shortly afterwards when the CEO was like, oh my God, we're actually under attack. But it was also a great example of how it doesn't matter how sophisticated you think you are, you're probably not paying enough attention to your email. I was actually collaborating with someone on the security team to build this. And I asked them, is it ethical to phish for OAuth credentials? And if so, could you invite me to a Quip document? It's pretty obvious what I'm probably intending to do at this point. I happened to be in Sydney at the time, so I sent him the email quite late at night PST and said, hey, I've sent you an email, let me know what you think. 12 hours later, I was like, hey, like, you could look at the email by now. It's not going to take that long. He was like, oh, I don't think I got it. It's like, I'm pretty certain I sent it to you. To be fair, I don't BCC these emails to myself, so maybe something happened. Like, here is the subject to search for. He's like, no, I really don't think I did. I'm like, are you really certain? Turns out he got the email, he clicked through the link, he saw this, he thought, wow, it's sketchy that they're asking for those permissions. And he was reaching out to our contact for this, saying, hey, we need to talk about security and why you're asking for access to email. Like, he legitimately knew I was sending him a phishing email. He is on the security team. He knows the form of this phishing email, and he still thought it was legitimate. Like, I do not think it is possible to train someone such that they will not fall for these. It is important for you to actually cryptographically prevent them from giving credentials away, because I'm certain that I would also fall for one of these one day, despite having crafted a ton of them internally. This really can happen to anyone. So it also kind of underscores the importance of knowing what all of your different auth flows are. Right? Like, this is something we didn't really know we had until I happened to watch someone log into a service and go, that seems not cool. We shouldn't do that. So let's chat a bit more again about phishing training. We've said that it's ineffective. We've said that people will fall for things anyway. It doesn't matter what you do. But it is actually still an important thing to do. One of the reasons is that everyone thinks they're immune to it until they fall for a campaign. I've not met one person who thought, you know what, yeah, I could totally be phished. Everyone's like, nah, that happens to like your old relatives when Nigerian princes email them. That doesn't happen to me. It has a lot of benefit in making people sympathetic when someone else is phished, if they've also been phished along the way. And the other thing is, you should think about what you're trying to achieve with this. Even if you're just trying to convince someone like, oh, you could be phished as well, there's still a lot of value in things that you can't otherwise prevent, right? People do need to be trained, their system 2 needs to be trained to identify what a phishing email is, even if their system 1 is gullible. Because things like action-based phishing, people are probably thinking a little bit harder when they're transferring millions of dollars offshore. But you should try to make transferring millions of dollars offshore in an email a rare enough occurrence that they actually do think about it. But you should still train like finance teams about the fact that that's not a good idea to do. And the other thing is you should focus on tooling, right? So I mentioned how we've actually cryptographically tied most of our sites to particular things. We've also built tools internally to help people identify phishing emails. In Gmail these days, we actually highlight all mail that's not from a stripe.com sender in a different color. Not a particularly dangerous color. It's not like blaring red. It's a gentle purple. But the idea is that way when someone pretends to be someone internally by faking an email address, it's that little bit easier to spot it and to recognize that maybe it's not actually the CEO from a train asking you to wire money offshore. The biggest thing here is really, with phishing training, you need to encourage people to slow down, but you need to be realistic about when they're going to do that. If you're asking them to slow down and carefully evaluate every single email they send, it's probably not realistic to ask them to do that. If you ask them to slow down when they're touching a ton of money or otherwise giving access to things, that is a more realistic thing to ask them to do. But the most important thing here is to remember to remove humans from the authentication loop entirely, because anyone can fall for this, because in the end, we're all human. Question time. Yes, go for it. So the question is, do I have a slower paced presentation on U2F? I do not, but I am happy to talk about it slower afterwards. Yes?
Silly question, but does the YubiKey require cookies to be enabled?
Mm-hmm. So the question is, does a YubiKey require cookies to be enabled? It doesn't, but once you've authenticated someone, every single action they take is going to involve touching the key again if you can't store somehow on the server side that they've already authenticated. So it does require browser support as well. It currently only works in modern versions of Chrome and Firefox with some extensions. I believe that Microsoft Edge is planning to add support soon. Firefox are planning to build it in, I think, by the end of the year, but they've been having a little bit of difficulty prioritizing it. And I have no idea what Apple's stance on all of this is with Safari. Cool. Okay. Feel free to come and ask me questions afterwards.